This is chapter 9, section 3, and this is rotations. You may just want to watch today. You may just want to leave your book open. You're going to have work to do, but you may just want to watch this and not try to copy down everything I do. Because I think you'll get more confused doing that. And then if you need to get it into your notes, then go home and watch it on Edline, and you can do it slower then. What you're going to be doing today, the first thing that you're going to be doing is you're going to be taking a shape. All right, let's say you get a triangle. And you're going to rotate this triangle around a point. All right, it's going to rotate around a point here. We'll call this C, center of rotation. And this is triangle LOB. Now, a rotation is when you take this shape and you orbit it around C. Okay? And when you're dealing with rotations, the most important thing to remember is that the distance from O to C, okay, is going to be the same as it is from C to O prime. So if we're going to rotate this thing 100 degrees counterclockwise, all the rotations in this book are counterclockwise unless they tell you different. To rotate this shape 100 degrees counterclockwise, or orbit it 100 degrees counterclockwise around C, we need a segment that goes from O to C and then from C to O prime. From C to O prime needs to be the same distance as OC, and it needs to be at 100 degrees. Okay? So right now, tell me when the red line I'm drawing looks to be the same distance as OC. You have to help me because I'm not. Now, what degree angle does that look like? Real close to 90, right? So would you agree that that's about 100? Okay. So you've got C, O, and you've got C, and we're going to take it to O prime. All right? And that piece is congruent to that piece. And what's this angle measure? 100, because we're rotating the shape 100 degrees. Does everybody see how I've moved that point or rotated that point? This point has orbited or rotated around C. It's stayed the same distance from C the whole time, hasn't it? Okay, because OC and O prime C are the same distance. And if this is a 100-degree angle, and this point sits on one of the sides of the angle, then it's 100 degrees away from O. Now, if you do the same thing for the other points, if you draw a line from L to C, okay? Now I need a line or a segment that's going to go from C to L prime, right? It's got to be the same distance, so tell me when it's about the same distance. Okay, that looked like about 90. So we'll go a little bit more and make it 100. Okay, so now what's this point going to be? That's going to be your L prime. Good. L prime. And this is the same as this, isn't it? And what's that angle measure? 100. Good. All right, so you got to do it one more time. You're going to go from B to your center of rotation. And now you got to do the same thing out here. Same distance. Tell me when. Is that about 90? Yeah. So we'll make that about 100. And that's going to be called B prime. B prime. And isn't this the same as this? And what's that angle? 100 degrees. Good. So now if you connect these, that is LOB rotated 100 degrees about C. I know there's a lot of lines up there. But can you see how corresponding points are staying the same distance away from the center of rotation? Okay? Does that make sense? It's orbiting around that, isn't it? Okay. Good. Turn the page. Now we're going to talk about a shape rotating around or the center of rotation being inside the shape or in the middle of the shape. So I need my textbook back. All right, we're looking at a pentagon here. The center of a regular polygon is the point that is equal distance from the vertices. The center and the vertices of a regular n-gon determine n-congruent triangles. What that means is however many sides there are in a regular polygon tells you how many triangles you can get out of that polygon. In this case, point X is the center of a regular pentagon, PENTA. What is the image of the given point or segment for the given rotation? All right. Can you picture this shape rotating on top of itself?
Yes.
Okay. If the shape has 5 sides, all right? If the shape has 5 sides and you take 360 in your calculator and divide it by 5, what do you get? 72 degrees. So each time we turn this shape and it sits on top of itself again, how many degrees are we rotating? 72 degrees. Okay? So here's the question. What is the image of a given point or segment for the given rotation? 72 degree rotation of t about x. So we're going to take t, we're going to rotate it around x 72 degrees. So what will it become? It'll become n, won't it? If you take this shape and rotate it 1 turn, it'll look like itself again, won't it? You'll take t and you'll turn this thing to here. That's 72 degrees. So t will become n after 72 degrees.
Will it be called n or will it be called t prime?
Right now, it would be called n because it's easier to see what it would turn into. After 144 degrees, what would it be? It would be E, wouldn't it? After 216 degrees, it would be P, wouldn't it? Okay? Every time you turn it once, you go 72 more degrees. 216 degree rotation of Tn about x. Now you're rotating a side. This side right here. And if you rotate that side, this would be how many degrees? 72. This would be how many? 144, right? And this would be 216. So what's Tn going to become after 216 degree rotation about x? PA, good. Okay? After a 360 degree rotation, what would it become? Become Tn again, wouldn't it? It would be back on top of itself if you rotated it 360 all the way around. Clear? Nice. What is the image of E for a 144 rotation about x? All right, E for 144 degrees about x would become? A, very good. 72, 144. 72, 144 would become A. 216. What's next? 288 and then 360, right? Because it's got 5 sides. So 360 divided by 5 gives you each rotation. Alright, now you got a different shape, don't you? Here's your center of rotation, C. What is the angle of rotation in degrees about C that maps Q to X? So you're going Q to X. Alright, so now you got a different shape that you're dealing with, don't you? It's a triangle. So what is each rotation now? 360 divided by 3, which is 120. So now to get from Q to M, how many degrees is that? Good. From there to there is 120 degrees. So you're going Q to M to X. Bring that here. Just bring it here. Carlos. Bring it here. Bring it here, Carlos.
Here it is.
So to get from Q to X, how many degrees? Q to M is 120. You got to go all the way to X. So 240 degrees. Okay? All right, look over here at problem 4 on page 579. This is the same concept as thanks. Is when you were moving something last week twice. Now you're going to rotate it twice. It's a composition. It's a 30-degree rotation and a 60-degree rotation. So what's the total rotation going to be here? 90 degrees. And what's your center of rotation? K. So can you picture this shape orbiting around K? All right. And if you read through the problem and you look at the examples, they do it step by step. But wouldn't this thing kind of look like that? After it rotated, how many degrees do you think this would be? How many degrees do you think this would be? 90, wouldn't it? Doesn't that look like about a 90-degree angle? Okay. And if you did this and this, okay, this shape down here, how many degrees would that rotation be? 180. And then if you did it here, okay, so that's 90. And then to here would be 180. And to here would be 270. And when you get it all the way back home, that's a 360 rotation. All right. But when you're asked for a composition of 30 and 60, just add them together and rotate it once, 90 degrees. Okay? All right, this got it question. What are the coordinates of the image of a point? -2, -3. After or for a composition of two 90-degree rotations. So if it's going two 90-degree rotations, how many is it going? It's going 180 degrees. So if you plot it at -2, 3, so -2 and 3, and they call it A. And you're going about the origin. So your center of rotation is right here, isn't it? So if you rotate this thing 90 degrees, where will it be? 90 degrees. -2, -3, wouldn't it? Be right down here. That would be 90 degrees. If you rotate it another 90 degrees, where will it be?
2, 3.
Good. It will be at 2, -3. So you can call that A prime, and it's at 2, -3. And there's your next 90-degree rotation. All right. If you had to go another 90,
2, 3.
very good. You'd be at 2, 3, and that'd be 90 more degrees. All right. And then finally, you're back home with another 90-degree rotation because you went 360, didn't you? Okay? Any questions? Page 580. 1 through 16 today.